Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about carboxylic acid, preparations and their properties. This is important for 10 plus 2 and BSc first year of chemistry students. So I hope this video will be helpful to you. You know the functional group of carboxylic acid RC double bond OH. Organic compound which contains carboxyl functional groups are called carboxylic acid. The name carboxyl is derived from carbonyl. You know the CO, the functional group of carbonyl which is present in acetone, and hydroxyl OH, you know the alcohol. So because in the carboxyl group these two groups are directed bond to each other. So look at here RCO which is carbonyl, OH which is hydroxyl, then it becomes carboxylic acid. So carboxyl groups are further classified as monocarboxylic acid, dicarboxylic acid and tricarboxylic acid. Monocarboxylic acid means it contains one carboxyl group, dicarboxyl means 2 and tricarboxylic acid means 3. The long chain monocarboxylic acid are commonly known as fatty acid. So acidity of carboxylic acid. Carboxylic acid are weak acid, very weak, and ionized in water according to the following equation. You can see this acid in water in equilibrium, it gave H plus, that is H3O plus, this indicating acidic in nature. The equilibrium constant you can calculate K equilibrium concentration of RC00 minus NH3O plus divided by RC double bond RCOH and concentration of water. The K value of carboxylic acid falls within the range of 10 to the minus 5 to 10 to the minus 4. The K value of acetic acid is 1.74 into 10 to the minus 5. The ionization constant you can calculate Ka with the help of, then pK is equal to minus log Ka. So why carboxylic acid is more acidic than alcohol? You know the lesser the pKa, greater the acidity. pK value for acid is 4 to 5 and alcohol is 14 to 16. So ionization of carboxylic acid leads delocalization or shifting of negative charge from one oxygen to another. Hence separation and creation of unlike charge to produce force drive to ionize. This is the reason carboxylic acid is more acidic than alcohol. So equilibrium shifted to right side and carboxylic acid ionizes faster than alcohol. So ionization of alcohol to produce anion and there is no delocalization of charges and hence ionizes slowly and equilibrium shifted to left. Look at here. But this thing not happen in alcohol. So why carboxylic acid more acidic than alcohol? There is a difference in electron negativity between carbon and oxygen. There is a partial positive charge on carbonyl carbon which induces polarization of the electrons in OH bonds. You know the OH bond here you can see. So electron withdrawing effect of carbonyl carbon weaken OH bond and facilitate ionization of carboxylic acid compared to alcohol. The effect of substituents on acidity of carboxylic acid. Electron withdrawing groups like chlorine, bromine and fluorine increases acidity. Electron withdrawing groups withdraws electron density from the carboxyl group and equilibrium shifted to right that increases acidity of carboxylic acid. Electron donating group OH NH2 decreases the acidity. Electron donating group add electron density to carboxyl groups and equilibrium shifted to left that decrease the acidity of carboxylic acid. Now it is clear to you, you can look at here RC double bond OH acid, weak acid. Acyl chloride more acidic than acid, and amide less acidic than carboxylic acid. What does it mean? Why acyl groups is more acidic than amide? Because here Cl, electron withdrawing groups, here NH2, electron donating groups. Now you understand, and this question is very important for NET and GATE examinations. Now, physical properties of carboxylic acid. You know the lower carboxylic acid are liquid with these agreeable odors. Boiling point and melting point of carboxylic acid increases with increased molecular weight. Carboxylic acid is associated with the dimeric structure and the intermolecular interaction with each other, so it has higher boiling point. You know the carboxylic acid also interact with water molecules by hydrogen bonding through carbonyl groups and hydroxyl groups, and because of hydrogen bonding interactions, carboxylic acid are more water soluble than alcohol, ether, aldehyde, and ketones. IR spectroscopy, you know, IR stretching of carbonyl is observed at 1700 to 1725 centimeter inverse. In NMR spectroscopy, the chemical shift of carbonyl compounds are observed at 2 to 2.5. Now, methods of preparation of carboxylic acid. Oxidation of primary alcohol and aldehyde, oxidation of alkene, hydrolysis of nitriles, hydrolysis of ester, carboxylation of Grignard method, carboxylation of alkene from malonic ester. So there are 7 methods here which I mentioned. First, oxidation of primary alcohol and aldehyde. Remember, oxidation of alkene, hydrolysis of nitriles, hydrolysis of esters, carboxylation of Grignard methods, carboxylation of alkenes, and from malonic ester. Now, learn one by one. You can see the oxidation of primary alcohol and aldehyde. Alcohol, it gives acid. If you take the specific ethyl alcohol, it gives acetic acid. Now, oxidation of alkene. Take the 2-butene, you will get aldehyde. On oxidation, you will get the acid. Now, method of preparation of carboxylic acid, third method, hydrolysis of nitrile. You can see nitrile gives the carboxylic acid on hydrolysis in acidic or basic solutions. Hydrolysis of ester. You can see the sodium acetate undergo acidification, it gives acetic acid. Grignard methods. Rx react with magnesium, RMgX, it react with carbon dioxide. You will get the acid. So, carboxylation of alkene. You can see the carboxylation of ethene, it gives propionic acid in presence of phosphoric acid. Malonic ester, sodium diethyl malonate, this compound, and you can see the alkyl halide, it gives this on hydrolysis, it gives diacid, and after decarboxylation, you will get the carboxylic acid. So there are 7 methods, many methods, but I have mentioned here 7 methods you have to keep in your mind. Now, reaction of carboxylic acid. Salt formations, formation of acyl halide, formation of amide, formation of anhydride, formation of ester, esterification using diazomethane, reduction with the aluminum hydride, reduction with diborane, and alpha halogenations. 9 reactions of carboxylic acid. First, salt formation. Second, formation of acyl halide. You know the structure of acyl halide. Amide, anhydride, ester, esterification using diazomethane, reduction with the aluminum hydride, reduction with diborane, and alpha halogenations. Look at here salt formations. React with the base, it forms salt. Formation of acyl halide. You can see the OH replaced by Cl in presence of PCl5 and thionyl chloride. Formation of amide. You can see it reacts with ammonia, it gives the salt and then carboxamide. Formation of anhydride. 2 acetic acid, it gives acetic anhydride. Formation of ester. Alcohol and acetic acid combine together and forming ester. Esterification using diazomethane. You can see how diazomethane react and forming methyl ester. Now, reduction with lithium aluminum hydride. If you have acid, it reduces in the presence of lithium aluminum hydride, you will get the alcohol after reduction. Reduction with diborane. You can see the BF3, THF, tetrahydrofuran, water, HCl, benzoic acid converted into benzyl alcohol. Now, last reactions of acid, alpha halogenations. You can see the alpha halogen, the hydrogen which is near to functional group, that is alpha, which is replaced by chlorine in this reaction. So this is the alpha halogenation reaction. So propionic acid give chloropropanic acid. Now friends, qualitative test for carboxylic acid. How you will confirm carboxylic acid present in any sample? So test sodium bicarbonate test and observation inference. Sodium bicarbonate test, take 2.3 to 0.3 gram, little bit of compound and add 2 ml saturated solution of sodium bicarbonate. A strong evaluation of carbon dioxide means presence of carboxylic acid. Do the esterification test, little bit pinch of solid sample in test tube, 10 drops of ethyl alcohol you can add and 2 drops of concentrated sulfuric acid. Fragrant smell, then you can inference like carboxylic acid present. And fluorescein test, 0.1 gram of sample plus 0.1 gram resorcinol and plus 0.5 ml of concentrated sulfuric acid. Heat the mixture and pour into beaker containing dilute sodium hydroxide. Green fluorescence, then carboxylic acid presence. Now